In this video, we're going to look at the unit circle and the special angles 30, 60, and 45 degrees, which are the three angles you're going to come across more than any other in high school or leaving cert maths. So if we create a unit circle, with a radius of 1, and if we draw a 30-degree angle in here. So imagine that this is 30, and that this is 30 as well, and these are both 1. So what angle have I got here? I have 60, and what angles would these two be here? Well, because of my 1s, the angles at the end of these sides must be the same length, so these must be 60. So now I've actually got an equilateral triangle with 3 angles being 60. So this side along here must be 1. So this one must be a half, and this one must be a half. So if I take out this right angle triangle from the diagram, from the upper half, I've got a half, I've got a 1, I have a 30, and I have a 60 on my right angle. Now let me get this side here x. X is going to be equal to the square root of 1 squared minus a half to be squared. So x is going to be the square root of 1 minus a quarter, which is the square root of 3/4, and x is equal to root 3 over root 4, or root 3 over 2. And this brings us into the memorization of these angles and their ratios. So what can we say about the cos of 30? Cos of 30 is a over h, which is x over 1. Cos of 30 is equal to root 3 over 2 divided by 1, so we don't need to put that in. The sine of 30 is equal to o over h, which is a half divided by 1, or just a half. And the tan of 30 is equal to o over a, which is a half divided by root 3 over 2. The denominators are the same, so the tan of 30 is 1 over root 3. Let's have a look at the sine angles over here on the left, or the 60-degree angles, the sine of 60. So we're up here now in this 60-degree space. So the sine of 60 is o over h, which is root 3 over 2 divided by 1, or just root 3 over 2. The cos of 60 is equal to a over h. My a is the half here. Half divided by 1 is a half. And the tan of 60 is equal to o over a. So o is going to be the x, which is root 3 over 2, divided by the adjacent, which is 1 over 2. The denominators again cancel, and the tan of 60 is equal to root 3. So using the unit circle to set up how we find the ratios for cos of 30, sine of 30, tan of 30, tan of 60, and so on. So let's have a look at the unit circle now for the 45-degree angle. You've got your circle. Again, we'll use this radius as 1. So if I just connect these 2 points, this one and this one, now I've got an isosceles triangle with a right angle. Let me just take it outside. My isosceles triangle. So these have to be the same length. They're both away from the side at the end of the side, that's length of 1. So what's my x going to be in this case? X is going to be equal to the square root of 1 squared plus 1 squared, which is equal to the square root of 2. So now let's look. Cos of 45. Doesn't matter which one we take, because the adjacent, let's take this one down the bottom, we'll stick with this one. The cos of 45, a over h, 1 over root 2. And this is why the sine and cos of 45 are equal. Sine of 45, o over h, 1 over root 2. And the tan of 45 is in 2 straight sides, 1 over 1, which is equal to 1. So a short little video just introducing the special angles 30, 60, and 45 degrees.